Welcome to another episode of Explained by AI. Today we're diving deep into black holes. I bet you've heard of them, right?
Absolutely. They're one of the most fascinating objects in the universe.
But they're also pretty mysterious. I mean, how do we even know they're out there if we can't see them?
Yeah, it's like trying to find a tiny speck of dust in a giant room. It's really hard to spot them directly.
Okay, so how do scientists find them?
Well, they look for clues, like how things behave around them.
Like what kind of clues?
Imagine you see a bunch of leaves swirling around really fast, but there's no wind. What would you think?
Like something invisible is making them move.
Exactly. Scientists look for stars that are moving really fast around an area where there doesn't seem to be anything.
That's pretty cool detective work. So that's how they know where to look. But how do black holes actually form?
Well, it all starts with giant stars, way bigger than our sun.
I'm talking massive,
It's
right?
yeah, huge. And when these stars run out of fuel, they kind of collapse in on themselves.
Like a balloon with the air let out?
Kinda, but way more dramatic. Imagine all that stuff in the star getting squeezed into a tiny, tiny point.
Wait, a tiny point. How is that even possible?
It's mind-blowing. Right. That point is called a singularity, and it's where gravity becomes super strong.
Like super, super strong.
So strong that nothing, not even light, can escape. And around that singularity is the event horizon.
Okay, event horizon. What's that?
Think of it like a boundary, a point of no return. Once you cross it, you can't come back out.
Like falling into a bottomless pit.
Exactly. And that's because the gravity is just so strong.
Okay, now I'm starting to get a little creeped out. But are all black holes the same size? Or are there like different kinds?
There are actually a few different types. The smallest ones are called stellar black holes. They form from the collapse of a single star.
So even a single star can create a black hole.
If it's massive enough, yes. But then there are supermassive black holes.
Supermassive. Those sound even scarier.
These are millions or even billions of times heavier than our sun. And guess what? We think there's a supermassive black hole at the center of almost every galaxy, including our own Milky Way.
Wow. So we have this giant invisible monster lurking at the center of our galaxy.
Well, monster might be a bit dramatic, but it definitely has a huge influence on the galaxy.
So we have these supermassive black holes shaping entire galaxies, but we can't even see them directly. How do scientists study them if they're invisible?
That's a great question. One way is by looking at how light bends around them.
Wait, light can bend? I thought it always traveled in a straight line.
Well, according to Einstein, massive objects actually warp the fabric of space-time. It's like putting a bowling ball on a trampoline.
Oh, I see. So the bowling ball makes the trampoline dip, and anything rolling nearby will curve around it.
Exactly. And black holes are like cosmic bowling balls, warping space-time so much that light actually curves around them.
Whoa, so black holes are like cosmic funhouse mirrors, bending and distorting light.
That's a great way to put it. And that's how scientists can actually see the effects of black holes, even though they can't see the black holes themselves.
So it's like seeing the shadow of something that's invisible.
Precisely. And this warping of space-time is one of the most mind-blowing aspects of black holes.
Okay, my mind is officially blown. This is incredible. But what about this fabric of space-time thing? It sounds like something straight out of Star Trek. Can you explain what that actually means?
Sure. It might sound like science fiction, but it's a real concept. Think of space-time as a giant sheet, like a really big, stretchy fabric.
Okay, I'm picturing it.
Now imagine that massive objects, like stars and planets, create dips in that sheet.
Like if you've been bowling ball on a sheet, it would make a dent.
Exactly. And the heavier the object, the deeper the dip. Now, black holes are so massive that they create the deepest dips, like huge craters in space-time.
So those dips are what cause things to fall toward black holes. It's like rolling down a hill.
You got it. And it's not just matter that gets affected. Light, even though it doesn't have any weight, also gets bent by those space-time dips.
So light actually follows the curves in space-time.
Yep. Even though it travels at the fastest speed possible, it still has to follow the path laid out by gravity.
That's wild. So black holes are like cosmic traffic cops, directing the flow of light and matter.
You could say that. They really do have a huge impact on the structure of the universe.
This is all so mind-blowing. Black holes are like the ultimate cosmic mystery, pushing the limits of what we know about physics and the universe.
And we're only just beginning to scratch the surface. There's so much more to explore and understand about these incredible objects.
Well, my brain might need a little break to process all this incredible information, but I'm definitely hooked.
Me too. Black holes never cease to amaze. All right, ready to jump back in?
Oh yeah, My brain's recharged and ready for more black hole craziness.
Great. So we've talked about how they form, how we find them, and even how they kind of evaporate over time. But what about the stuff that falls into a black hole? Where does it go?
Yeah, that's a good question. It's like gone forever.
That's the thing. It's one of the biggest mysteries in physics called the black hole information paradox.
Okay, a paradox. Those always sound complicated.
Well, it's basically a conflict between two really important ideas in physics.
Okay, lay it on me.
So, one idea is that information can't be destroyed.
Information like in a book or something.
Kind of, but think more like the information that makes up everything around us, like the way atoms are arranged in a chair or a tree. The idea is that even if you burn a book or chop down a tree, the information isn't really gone, it just changes form.
Okay, so the information's still out there, just mixed up.
Exactly. But here's the problem. Black holes seem to break that rule. If something falls into a black hole, according to what we know, it's gone forever, information and all.
Wait, so black holes are like cosmic shredders, destroying information. That doesn't seem right.
You're getting it. And that's the paradox. It goes against this idea that information can't be destroyed.
So how do we solve that? Do we need to rewrite the rules of physics?
Well, physicists are working on it. There are a few ideas out there.
Like what?
One idea is that the information isn't destroyed, but it gets spread out on the surface of the black hole, on that event horizon we talked about.
So it's like writing a message on a giant balloon.
Kind of. As things fall into the black hole, their information might get encoded on the event horizon.
Okay, but wouldn't that information eventually get sucked in too, as the black hole grows?
That's where things get really weird. Remember Hawking radiation?
Yeah, the stuff that makes black holes evaporate.
Right. Well, some scientists think that Hawking radiation might carry that information back out into the universe, just in a really scrambled, messy way.
So it's like the black hole spits the information back out, but it's all jumbled up.
Exactly. It would be a huge challenge to try and put that information back together.
Like a giant cosmic jigsaw puzzle. But are there other ideas out there?
Yeah, there are some who think that the information might be preserved inside the black hole somehow, maybe in a way we don't understand yet.
So it's like a cosmic safe deposit box holding on to the information.
Possibly. And some theories even suggest that the information might travel to another universe or dimension.
Whoa. Like a portal to another reality.
It's a pretty wild idea, but it's one possibility.
This is all so crazy. The more we learn about black holes, the more questions we have.
That's the beauty of science. There's always something new to discover, and black holes are full of surprises.
Speaking of surprises, we talked about different kinds of black holes. Are there any other types out there besides stellar and supermassive ones?
Good question. There's a third type that falls in between called intermediate mass black hole.
Intermediate, so like the middle child of black holes.
Yeah, you could think of it that way. They're bigger than stellar black holes, but much smaller than supermassive ones.
So how do they form?
That's still a bit of a mystery. We think they might form in dense clusters of stars, where a bunch of stars are packed close together.
So it's like a cosmic traffic jam. And sometimes the stars bump into each other and merge to create a bigger black hole.
That's one idea. And finding these intermediate mass black holes could help us understand how those supermassive ones form, which is still a big puzzle.
So it's like solving a cosmic detective case. We need to find these missing pieces to understand the whole story of black holes. But have we actually found any of these intermediate mass black holes?
There have been some clues, some objects that seem too big to be stellar black holes, but too small to be supermassive.
So we're still searching for that definitive proof.
Yep. The hunt is on, and finding them would be a huge step in understanding the whole black hole family.
This is all so fascinating. Black holes are like a cosmic puzzle, and we're slowly piecing together the pieces.
And each new piece we find leads to even more questions. Black holes keep us on our toes.
Well, my brain is definitely getting a workout today. Black holes are seriously mind-blowing.
They definitely are. And there's still so much more to uncover.
I can't wait to hear what else is out there. What other black hole mysteries await us?
So we've gone deep into a black hole, looked at how it's made, and even talked about what happens to stuff that falls into. But are you ready to go even further? To the very center.
Let's do it. I'm ready for anything. What's at the center of a black hole anyway? That singularity thing.
That's the singularity. It's where things get really wild.
How wild are we talking?
Well, the singularity is a point where our current laws of physics kind of break down.
Like they don't work anymore.
Pretty much. Gravity becomes infinitely strong, space and time get all warped. It's a place we can't even really imagine.
Okay, now I'm really curious. So what could possibly be at the singularity? What happens to matter when it gets squeezed down to a single point?
That's the big question. Nobody knows for sure. Some theories say it could be a gateway to another universe.
Like a portal to a whole other reality.
Maybe. Others think it might be a place of pure energy, a chaotic sea of quantum stuff.
So we could be talking wormholes, parallel universes, or even the birth of new universes. That's like the ultimate cosmic mystery.
It really is. The singularity is a place where science fiction and reality kind of collide.
So black holes aren't just these destructive things. They could be connected to all sorts of crazy possibilities.
Exactly. It shows us how much we still don't know about the universe.
Speaking of things we don't know, we talked about getting energy from black holes, but are there any other ways we could use them, like for travel or communication?
That's getting into some pretty far out territory. But yeah, the crazy physics of black holes might allow for some wild possibilities, even if we're nowhere near being able to do them yet.
Okay, I'm game. Let's speculate. What kind of black hole tech could we dream up?
Well, one idea that's been around for a while is wormholes, those theoretical tunnels through space-time.
So, like shortcuts to the universe. We could travel to other galaxies in an instant.
That's the idea. But remember, wormholes are still theoretical. We haven't found any proof they exist. And even if they do, using them would be incredibly difficult and dangerous.
I guess it wouldn't be as easy as hopping on a spaceship.
Not quite. We'd need to figure out how to keep them stable, how to navigate through them, and even how to avoid those tricky time travel paradoxes.
Yeah, going back in time and accidentally messing things up could be a problem. But hey, it's fun to think about, right?
Totally. Okay, back to reality for a sec. Besides all the theoretical stuff, is there anything we can learn from black holes that could actually help us here on Earth?
Absolutely. Studying these extreme environments can teach us a lot about gravity, matter, and energy, and that knowledge could lead to all sorts of technological advances.
Like what?
Well, understanding black holes could help us develop new ways to generate energy, improve space travel, or even create new materials with amazing properties.
So even though they're these distant, mysterious objects, black holes could actually have a real impact on our lives. Exactly. Studying them isn't just about satisfying our curiosity. It could lead to some truly groundbreaking discoveries that benefit all of humanity.
This has been an incredible journey. We've explored the anatomy of a black hole, pondered its mysteries, and even imagined the possibilities.
And the best part is, there's still so much more to learn. Black hole research is just getting started, and who knows what amazing discoveries await us.
I can't wait to see what the future holds. Black holes are definitely one of the coolest and most mysterious things out there. What do you think? Do you have any topic that you would like to have explained? Drop it in the comments. Until next time, keep looking up and keep wondering.